Okay, so today's lesson in our unit Light and Optical Systems is topic 3, which is on refraction. So just a quick recall from last week when we were looking at reflection. Reflection occurs when light rays bounce off of objects, and the direction in which reflected light rays travel, they can be predicted by using the law of reflection. Where any image will be located in a plane mirror, it can be predicted, okay, using that law of reflection and those ray diagrams we were looking at. But refraction, however, it is different. Refraction is the bending of light. All right, so the bending of light when it travels from one medium to another. So for example, air and water, those would be two different mediums. So light bends because it changes speed when it moves between materials that have different densities. So light usually travels more slowly in comparatively dense material. And the bending of light makes the object's image appear to be in a different position from where the object really is. So if we look at this image here, we're looking at the fish here. The apparent position when you're looking from air to water looks like it would be here, but the actual position of the fish is here, and it's because of that bending of light. So the bending of light, it can make it difficult to see where an object is located in the water. And just a note here, in the air, light travels at about 300,000 kilometers per second, and it will slow down to about 200,000 kilometers per second in glass and 165,000 kilometers per second in diamonds. All right, so just in this image here, we can see how it looks like this pencil is bent, right? We're just looking at a glass of water. And then it looks like the pencil is bent. However, we know the object is not really bent. It just looks that way because of refraction. So around a bend with light, so when light travels from one medium into a denser one, it will bend towards the normal. All right, so here we have water and here we have air, and this perpendicular line here is the normal. So we have an incoming, the incoming ray, and what we see when it goes into the denser material, which is the water, the ray has bent towards the normal. All right, so dotted line is showing what it would have looked like, but because we've gone into a denser material, the ray has bent towards the normal. The next image here, when light exits a denser medium, so it's exiting the water, and what we notice here, its direction of travel will bend away from the normal. So again, here is the normal, and here's the ray, and it looks like it would go showing the dotted line, but it actually bends away from the normal. All right, so make sure you know there what is happening when light is traveling from one medium to another one and at different densities. The angle of refraction. So how much bending depends on the type of material through which the light travels. And that new direction of the light is called the angle of refraction, which is shown by capital R. And basically, when the angle of incidence, capital I, increases, the angle of refraction also increases. All right, so looking here at this diagram, what we're looking at is that light is refracted as it passes through one medium into a denser medium. All right, so less dense out here, and through this substance, it is more dense. All right, so here is our incident ray, and here is our angle of incidence. So the ray is traveling, coming into this new material, and we can see our refracted ray through here, and then when it exits that denser material, this is our refracted ray. All right, so angle of incidence is here, and this is our angle of refraction. All right, angle of refraction. So refraction can also occur when light travels through air at different temperatures. All right, warmer air, it is less dense than colder air. So light will bend as it travels through different densities of air. That can result in a mirage. If you've ever noticed when you're driving, it looks like pools of water on the road. When you're driving on a really hot summer day, that's actually a mirage. The air that's closer to the ground is hotter and is less dense than the air that's higher up. So the light from the sky directed at the ground is bent upwards as it enters the less dense air. So that's something you've probably seen before here. Kind of looks like pools of water, but as you get closer, you're like, they're not pools of water at all. So it is the refracted light that is responsible for creating mirages. So air near the ground, it warms up. The light from objects that at a distance is refracted into a curved path. This causes the illusion of a water surface. It's really an image of the sky refracted by warm air near the ground. All right, so let's just take a look at this table here. What happens when light strikes a surface? So if it's absorbed, okay, it changes into some other kind of energy. Usually occurs on rough, dark, opaque surfaces. Some light is usually reflected off the surface. Most of it will be absorbed. When there is reflection happening, that's when light bounces off the surface and it'll travel in a new direction. Usually occurs best when it hits a smooth, shiny surface. What else happens? Some light is usually getting absorbed as well. And then we have refraction. This is when light travels through the surface, often in a new direction. This occurs when light strikes a different transparent medium. What else will happen at the same time is that some light is usually also getting reflected off the surface. All right, so basically all three light behaviors can happen all at once. Light from the sun can reflect off the still surface of a lake to produce a mirror-like reflection, but at the same time, the water can also absorb light, transferring the light energy into thermal energy. And then as you look down into the water from the shore, you might be uncertain about the location of objects on the bottom, and that's because of refraction as light travels from water into the air, okay, causing that bending. All right, so let's watch this video here on refraction.